Good morning, everyone. I'm Fenghua Wang. Now, I will present our works titled Liqnet, a real-time monitoring network for two-phase flow patterns. First, I will briefly introduce the background of this work. The identification of gas-liquid two-phase flow has been widely used in petrochemical, nuclear, and other related pipeline engineering fields. In practical application, the rapid determination of the flow patterns is essential for the pipeline equipment and the operator. Detecting slag flow accurately and rapidly can help the control system prevent and reduce the risk of an overflow of the separator on the off so platform in advance. With the development of machine learning, CNN imagine classification methods had been applied in flow pattern recognition. Table 1 summarizes the studies combining CNN and flow pattern identification in recent years. However, the above CNN algorithm applied to two-phase flow has fallen to deficiencies. One is the parameter size of the CNN model is insufficiently discussed. The other is the non-real-time nature of the CNN detection model due to the different source of the two-phase flow. It should be ensured that modem can run on mobile devices and has a real-time performance to meet the transferability of CNN. In summary, the main contributions of this paper are as follows. Real-time is regarded as a measure of two-phase flow classification for the first time. A consolidated database of 6,242 flow images is developed and employed to train and test the CNN models. Real-time classification model Liqnet for two-phase flow is proposed, and the experiments prove its feasibility. Next, I will present our proposed method. Since obtaining a large amount of flow imaging data from the open literature is not easy. These people collect flow patterns in our laboratory. Figure 1 shows the specific operation of imaging enhancement. Figure 2 shows the dataset expansion results. A is the original image. B is the image after random flipping and warping. Next, I will introduce the Liqnet model in order to reduce the amount of calculation. Depth-wise separator convolution is used in Liqnet. On the other hand, Liqnet adopted the China split technology, which firstly divided the network into branches and then use stepwise separable convolution to extract feature and build a feature pyramid structure. In order to further improve the accuracy of liquid, we propose the joint attention model, where with the output of the feature enhancement module with the joint attachment module. The specific weighting processing will not be described in detail. Then, we use the channel surfing model to reorganize the output of the model. Then, I will present our results. The experimental result of two-phase flow artification can be seen in Figure 5. Tip 2 and Tip 3. The higher the accuracy and the smaller the loss, which indicated that the model's performance is better. Liquid can achieve the highest accuracy with the smallest parameter amount and the shortest training time. In order to verify the universality of the model, we also tested on other two-phase flow dataset. The result also justify that the liquid has enough robustness to be extrapolated to other similar applications. F1 measure comprehensively consider precision and recall. The evaluation of CNN is more accurate, so it is used here as a measure of CNN accuracy. In Table 5, we can see that liquid has achieved the maximum F1 value on both stratified flow and pseudo slag flow. To further compare the difference of these three CA models, this paper visualized the network as shown in Figure 7. The brighter the color of the area in the figure, the more the natural network area about the area. The cooler the color of the area, less the natural network pay attention to the area. In contrast, the color distribution of liquid is more saturated and the effect is better. For schedules like flow, although more binary bisect has a red area in the chassis. This area doesn't appear on the gas-liquid separation interface, and the effect is not good. More Burnett version third has more red area outside the catheter, and the effect is poor. The distribution of the red area of liquid is concentrated on the gas-liquid interface, and the effect is better. Overall, the best experimental fact is liquid, followed by mobilnet worsen second and mobile net worsen third. Finally, is our conclusion. The main contribution of this paper can be summarized as follows. First, a two-phase flow imaging dataset is contracted. Second, a two-phase flow recognized network liquid is designed. Third, the variability of this method is valued through comparative experiment. That's all. Thank you.